Okay, welcome back to another video, and this time we're looking at solving simultaneous equations. Now, simultaneous equations will meet at a particular point, and that point where the two equations meet, two lines meet when you're graphing it, would have been your solution. Now, simultaneous equations can be solved using graph, simply algebraic methods, and also by matrices. This afternoon, we are focusing on solving algebraically. Now, the first thing that you need to do when you are working simultaneous equation is to label your equations, equation 1 and equation 2. The second thing that you need to examine is the signs that you're working with. Now, this is what we're talking about here. These two signs. Now, if these two signs are the same, then we call them like signs. If they are not the same, then they are unlike signs. The general rule for dealing with simultaneous equation is that if you are working with unlike signs, which means you're working with a plus and a minus, you eliminate the y first. So eliminate the y first. So if you're working with unlike signs, which means you're working with a plus and a minus, you eliminate the y first. If you're working with two like signs, so if you're working with like signs, you eliminate the x first. So that's the general rule. You eliminate the x first if you're dealing with like signs. If you're dealing with unlike signs, you eliminate the y first. In eliminating the x, you subtract. So by subtracting, and this one is by adding. In both cases, ensure that the variable you are eliminating has the same coefficient in both equations. You cannot get rid of any of the variables unless they are the same in both equations. Okay, so here we have two equations. Because the signs are not the same, we need to get rid of the y. And so to get rid of the y, we need to equalize the coefficient in both equations. So we're going to multiply this one by 2 and this one by 1. And so when we do that, we get 4x rather. So we get 4x plus 2y equals to 14. And we call this one equation 3. Here now, we need to add both equations. So we add 3 to 2. No longer 1, because these are the two equations that we're working with. And so we would end up with 5x plus 2 plus negative 2 gives us 0. 14 plus 1 equals 15. And so x is going to be equals to 15 divided by 3. X equals to 5. The next step is to substitute. So substitute x equals 5 in any of the given equation, either equation 1 or equation 2. And I'm going to be using equation 2. And so when I use equation 2, x equals 5. So we have here 5 minus 2y is equals to 1. See, I get rid of the x, so wherever x is, I'm going to put 5. And so this is going to be given me now 5 minus 1 equals to 2y, because I take over the negative 2y to the right-hand side, and I take over the positive 1 to the left-hand side. So I get 4 is equals to 2y. And so therefore, y now is equals to 4 divided by 2. So 2. So y equals 2. So your solution is x equals 5, y equals 2. And so if I should put these two values in equation 1, I would have no, something is not right here. No, this should be 5. Sorry about that. So this should be 5, and this should be 3. So here you'd have 3 equals 2y. So this is going to give me 2 here. So 2 upon 2 equals to 1. So x is equals to 3 and y is equals to 1. So I have done my corrections. And so if I should put in this into 1, I would have 2 times 3 to prove it, plus 1, which is equals to 6 plus 1 equals to 7. So remember now, we have 5x equals to 15. So x is equals to 15 divided by 5, which gives us 3. Right? The error was I put 3 here instead of 5. So I have made my corrections. And so I'm eliminating x equals to 3. I'm substituting rather x equals to 3. So when I substitute x equal to 3, I get 3 minus 2y equals 1. Take over the 1 to the right, to the left-hand side, and the negative 2y to the right-hand side. I get 3 minus 1 is equals to 2y. 3 minus 1 equals 2, which is 2 equals to 2y. And so y is equals to 2 divided by 2 gives me 1. And so that's my answer. Thank you very much for watching.